In this video, we are going to learn how to calculate moles to atoms or moles to grams. 1 mole is simply defined as 6 times 10 to the 23rd atoms or molecules. It really doesn't have to be atoms or molecules. It could be 6 times 10 to the 23rd of anything. Basically, a mole is a way of counting a really, really large number. So first off, we are going to learn how to convert from moles to atoms or molecules, or vice versa, from atoms or molecules back to moles. And it's simply using this equality. A mole is 6 times 10 to the 23rd atoms or molecules, and we are going to come back and use our want to know setup. So with our example, we have 2 of them. The first one, how many atoms are in 2 moles of helium? So we know we have 2 moles of helium. So we're going to write down 2 moles. And then we want to set it up with our want to know. We know moles. And the problem is asking us for atoms. So we're going to put atoms on the top. And then if we come over here, 1 mole is 6 times 10 to the 23rd atoms or molecules. In this case, we have atoms. So we'll put 1 on the bottom. That's a 1. And 6 times 10 to the 23rd on top. As this is on top, and this is a 1, we are multiplying fractions again. It will be 2 times 6, which is 12. And when you are multiplying with scientific notation, you multiply the numbers, and if this one is not in scientific notation, you really just carry this exponent. So 2 times 6 is 12, and it will be times 10 to the 23rd, which means 23 zeros after that. And it's divided by 1 on both sides, so we don't need to do that out. So your answer is just 12 times 10 to the 23rd atoms are in 2 moles. Alright, so to go backward, to do the opposite, we are starting with molecules in this instance, and we are going to moles. So we have 18 times 10 to the 23rd molecules. Oops, that's a 3. And we are looking to see how many moles that is. So we know molecules. And a common mistake people tend to confuse themselves is abbreviating molecules as mole. A mole is 6 times 10 to the 23rd of anything, whereas a molecule is a very, very, very small basic substance, basic unit of any substance. Molecules are what we know. Molecules go on the bottom. And we are looking for moles. So moles are what we want. They go on the top. Coming back to our equality, 1 mole is 6 times 10 to the 23rd. So we have 1, and down here we have 6 times 10 to the 23rd. I should have left more space so I could have put it up there, but that's all right. So now to do out the math, we are multiplying fractions, so 18 times 1 divided by 6. So 18 divided by 6 is 3. Times 10 to the 23rd divided by times 10 to the 23rd. That cancels out. Molecules divided by molecules cancels out, which leaves us in units of moles. So we have 3 moles. So now we know how to go from moles to molecules or atoms, and atoms or molecules back to moles. In order to find out how much anything weighs, we need to find this thing called the molar mass. So on our periodic tables, we've already been looking at the mass of an atom, and we haven't spent much time talking about units. And it turns out that 1 mole of any atom is that mass on the periodic table. So if you don't have your periodic table out, you should go get it. So let's look at hydrogen for a second. On hydrogen, it says the mass of hydrogen is 1. We can round to a whole number, just 1 gram. So 1 mole of hydrogen weighs 1 gram. If you look over at helium, the mass is 4. So that means that 1 mole of helium weighs 4 grams. So if we are looking to find the molar mass of something, it's just simply how much 1 mole, oops, sorry about that, just simply how much 1 mole of that substance weighs in grams. That's all that is telling us on the periodic table, but it's a handy reference because the mass of any element is right on the periodic table. So if we wanted to figure out what the molar mass of hydrogen is, we need to look up the mass of hydrogen, multiply it times 2 because there are 2 atoms in each molecule of hydrogen, and then add it to the mass of oxygen. So we have 2 hydrogens, and we have 1 oxygen. Hydrogen's mass on the periodic table is 1 gram, so we're going to multiply 2 times 1 to get a total of 2 grams, whereas oxygen's mass on the periodic table is 16. You can just round that up to 16, it's close enough. 1 times 16 is just 16. So now if we add the 2 grams from hydrogen and the 16 grams from oxygen, 2 plus 16 gives us the molar mass of water being 1. And that is really useful when we want to figure out how much a mole of something weighs, which is what we're going to do next. Alright, last thing. We are going to learn how to calculate grams to moles or moles to grams. And once again, it's using our want to know setup. So 1 mole is the molar mass of that compound. We just learned how to calculate the molar mass on the previous slide. So with our example, if we have 36 grams of water, we want to know how many moles that is. Well, grams is a measurement of mass. It tells us how much it weighs. So we need to convert 36 grams of water to moles using this equality. So we know, oops, sorry about that. So we know we have 36 grams of water. That's what we know, grams. We want moles, so we're going to put moles on top. And our unit equality tells us that 1 mole equals the molar mass of that compound. So we have 1 mole, and we need to know how much a mole of water weighs. Well, on the previous slide, we figured out the molar mass of water was already 18. We used that, we figured that out by using the periodic table, and the mass is on the periodic table. So we have 18 grams, and that's how much 1 mole of water weighs. So putting that over 1, we are multiplying fractions. Grams cancels out. 36 times 1 divided by 18 gives us 2.0 moles of water. Alright, so that is it for this video. If you need to review anything, please just rewind and rewatch the segment that is confusing to you. Alright, thanks!